Hi friends, great welcome to our Gspace education platform. Today let we all know the interesting informations about neuroscience in space.
Neuroscience in space. Space neuroscience is the scientific study of the central nervous system (CNS) functions during spaceflight. Living systems can integrate the inputs from the senses to navigate in their environment and to coordinate posture, locomotion, and eye movements. Gravity has a fundamental role in controlling these functions. In weightlessness during spaceflight, integrating the sensory inputs and coordinating motor responses is harder to do, because gravity is no longer sensed during free fall. Adaptation to weightlessness involves not just the sensory motor coupling functions, but some autonomic nervous system functions as well. Sleep disorders and orthostatic intolerance are also common during and after spaceflight. History of space neuroscience. The launch of the first living animal in orbit on Sputnik on November 3, 1957 marked the beginning of a rich history of unique scientific and technological achievements in space life. Sciences that have spanned more than 50 years to date. To date, only 3 countries, the United States, Russia, and China, have the capability to launch humans into orbit. However, 520 astronauts from more than 30 different countries have flown in space, and many of them have participated in space neuroscience research. Can a neuroscientist become an astronaut? Yes, you can become an astronaut if you are a biologist or most any type of scientist. What happens to your brain in space? Astronauts in the study were in space for an average of 5.5 months. Their brains showed fluid shifts. Our brains are about 80% water, and an increase of gray and white matter in the brain. The changes may help the brain adapt to the weightlessness of outer space. What are the operational aspects of neuroscience in space? Sensory and sensorimotor disturbances when arriving in low Earth orbit are well documented, the most known of these being space motion sickness (SMS). Individual differences, spacecraft size, and body movements cause SMS symptoms. Symptoms of space motion sickness: weightlessness, headaches, and fatigue to nausea and vomiting. Sensory functions in space. All living organisms on Earth have the ability to sense and respond to changes in their internal and external environment. Organisms, including humans, must accurately sense before they can react, thus ensuring survival. The body senses the environment by specialized sensory organs. Posture, movement, locomotions. Exposure to weightlessness causes changes to the signals from the receptors to touch, pressure, and gravity. Adaptive modifications in the central processing of sensory information take place to produce motor responses that are appropriate for the new gravitational environment. This is particularly true for the major postural muscles found in the lower legs. The modifications in posture, movement, and locomotion acquired in reduced gravity are then inappropriate for Earth's gravity upon return.